Hello everyone, welcome to Learning Activity 10, and this is Programming Syntax, and we're going to be working with we're actually doing a couple exercises in this lab. So to get us started off with this one, you'll want to go ahead and connect up your Arduino and go ahead and get it connected to the power. And then we're going to open up your sketchbook, and I'm going to put it off over here to the side. I've currently got this blanked out. There's just empty code that's on this right now. And what I'm going to do is we'll go through a coding exercise that shows the structure of the simplified C we're kind of working with, or Sketch, or Arduino programming language, APL. There's a couple. All those are, when I say that, we're kind of talking the same thing. So in the sketchbook, when we're creating a sketch, or we're creating C, or we're simplified C, that's what we're talking about. So go ahead and open this up. I have one that's called sketchnov7a.ino, and that's just a file. Now, if you come in here and you say new sketch, it's going to open up a new screen. And then it'll create a new instance of the IDE environment. We don't need to do that. I'm just showing that for illustration purposes. I'm going to go ahead and close this one down because I've already got one opened up. So you just go ahead and open up your Arduino IDE, get this connected, and then remember, you'll come over here and select your board. So you just come down here and select it. It should auto populate and find the Arduino Uno R4. So once you got that going, we're going to go ahead and get started on this lab here. And so we're going to start off with a block comment. So in this Arduino programming language, this is block comments are denoted by this /* and then completed with a */. This is actually pretty common. You see this in structured query language as well. The /**//. Line comments are different. Those are denoted by a --" in SQL and a hyphen in Python. So they don't. There's some similarities that they share between each other, but that's kind of where you'll see some of the similarities pop up. So anyway, block comment is a /*//. And I'm going to say this is where I can annotate my code. Yeah, and you could. So in this, what we're going to do is we're talking about the setup and the loop function. You're probably wondering, like, okay, what is that? But so the setup function. I'm just going to type this out. I'm not going to always do this. I'm just typing this out so you can kind of follow along. Sometimes I'm going to paste in, especially if they're going to be larger programs for some of our larger projects. So we'll paste in, but we'll code it out as we move along for some of the smaller stuff. So setup function. This executes one time and used to initialize variables, pin modes, as well as start using libraries. I'm going to make this a little cleaner, kind of taking some cues from Python, pip programming library style type stuff here. So we'll do that, kind of keep that clean. So, and then on this is the I'm going to do a line comment. So that's what this is. So this is going to be for programming libraries. Also, this is a line comment. And then I'm going to say, so for libraries here, it's different than in Python, where we do imports. So you do a pip install for a library if it's not part of the core functions, and then you'll do an import to bring the libraries in. Here you use a hashtag, so you say hashtag include, and then in this case I'm just going to say servo, I'm going to say servo.h, and that's for the of course the servo. We don't have it connected. These are just for examples. And then I'm going to say include the liquid crystal display. So that's going to be liquid crystal, liquid crystal H. All right. Oops. Liquid crystal, CRYSTAL. There we go. Liquid crystal. Okay. Servo.h. All right. So that's going to be for like programming libraries. Then you have what's called constant definitions, and we'll circle back at this on another time. Constant definitions. Let me just get it typed out here, and we're going to put in define max count 180. And I'll circle back on it here in just a sec. I'm just going to type this out. Okay, so then now that's for constant definitions. Then we've got a place for our programming variables. So I'm just going to put a line for that, programming variables. And you see how I'm kind of annotating using my line comments as I'm moving along. It's very helpful to do this. So I'm going to say servo, and then so that's the name of the variable, and we end that with semicolons, and then we're going to do liquid crystal, and we can just come up here and copy this. Liquid crystal, LCD, and LCD 3 through 8, 3, 4, 5, 6, 7, 8. Alright. Okay, so let's finish this up and then we'll talk through a few of these. Let's get over to the programming variables to make sure we've got that set up here. And then, so we've got that. Let's add one more in, an integer loop count. And we'll do that equal to 0 as our starting. And then we'll come up here and get the LCD taken care of. And then after that, let's talk about the setup. So for the void setup, this is where our, just like it sounds, it's where we do our, it executes one time, initializes the variable. We talked about that here. So I'm just going to put in setup area to get code running. So we'll just leave that, and we can say executes once. Okay. No, we didn't put up here. We described it in a little bit more detail. So down here, we don't know what the void loop does. So the void loop is, this is where our main code goes. So that's the put your main code here and runs repeat okay, repeatedly. And so that's what your that's what your loop. So that's loop function. Main code that executes Alright. Okay, so we're good there. So now what we're going to do is we're going to fill this in with some actual code that's going to run here. So in this void setup, we'll do serial.begin, and we can do a tab, and then we're going to do it at 9600 baud rate, and then we'll give that a semicolon, and then we're going to do a serial dot print line, a line print, so that one, and line print, and then say this is setup code, and that's cool. We're good there. All right, and then we're going to jump down to the main code piece here, which is going to be another line print, serial dot print line, print line. Oops, should have got a print. There we go. Print line. And when possible, I definitely would use the smart keys because they'll keep you from creating. It just simplifies and keeps you from making too many mistakes. This is loop code, and then we're going to say a delay on this, delay of 1,000, and then that should just about cover it. Okay, so I think that looks all good. I've got my Arduino here. We're not really actually going to, there is something's going to happen every time it executes one of the little LED will kick off. It should tick off, do a tick every time. It should blink every time it goes through a loop. So this is the basic overview of it from a real high level. So we've got our block comment up here. We've got our programming library, libraries. In this case, we're not using the servo or the liquid crystal. Those are just examples. Constant definition. So constant, define max count equal 180. So when we talk about constants, they're predefined expressions in the Arduino language. They make programming language easier to read, and so there's a lot of different constants. There's Boolean constants. They can actually be used for defining high and low, or true and false. Then you also have how constants can be used for managing voltage. They can also be used for managing the digital pinouts, and how those are controlled and configured, and they can be used for like LEDs and other stuff. Anyway, so constants, if you want to know more, you can look it up online, like constant, defining constants in Arduino, and then you can see all the different ways that it can be used. But that's your kind of quick textual definition for the lab here. Then we've got our programming variables, and we'll learn more about this as we move along, but this is just pretty straightforward, very similar to how variables are managed in other programming languages. You set you set the data type here, then you set the name, and then you set a value to that variable. Then what we do is we've got our setup area, and then we've got our main code execution that are set up with the void setup and the void loop. So that's it. That's the high level for most of what we're going to be doing is going to run into this. If there's anything extra as we move along we'll explain as we move along in our labs. I will stop to explain those. So, okay, this gets us going. So let's run this and then see if we get this to go and actually do a loop. So we'll do a verify, and then no. So I've got an error. So compilation error expected before. Oh, I think right here. Let's see. Yeah. Okay. So let's redo that. I forgot to put a semicolon there. So let's rerun that. And then looks like we might be all right now. All right. That looks like it's going. And so now it looks like it compiled. Now I'm going to upload it. I'm going to hit the upload here, and I'm going to move the Arduino so it's got, there we go. I'm going to go ahead and upload it to the Arduino R4. Okay, so then now it should be, yep, there we go. Okay. Okay, so you see that blinky LED that's kicking off? 1, 2, yep, there. So it's running, and that's good. But you'll notice here that you're like, hey, what's going on? Nothing's happening. Well, this is just the output. This isn't what would be the console output. I guess it is the console output, but this isn't quite the same as the way Python would work. You actually have to go to the serial. Let's see. We have to go to the a different place to look for what's happening. So we got to go to the serial monitor, and then this is where we can see So what it's doing is every time it runs through a loop, it's delaying for 1,000 milliseconds, so 1 second, and then it runs 1 second and then goes, this is a loop code. So so then this just keeps going infinitely. It doesn't stop, it just runs and runs and runs. And then so we can see that it's actually working. This is actually doing what it's supposed to do. And we created a program that did successfully executing a loop right now, which is basic, but again, this is just to demonstrate the programming syntax. So there's a couple other things I want to show you. So go ahead and save this code off. I'll actually have a copy of this code for you to use as well. I'll make sure that I upload these to Canvas so you have both the PowerPoint and the code base as you move along. Okay, the next one is I'm going to go ahead and we can just let this run. And then I'm going to actually back out of this. I'm going to delete everything here. I'm just going to delete all of that, and then I'm going to do a new straight up small program, and this one's just going to be for reads the value from an analog input pin and plots them on the serial plotter. And so that'll be our high-level block comment on what's going on. We're going to do void setup again, and typically this is created by default, and then we'll create the curly braces, and then we'll do the same thing here. I'm going to copy and bring this down for the void loop. This is going to be a small program. So this is exercise number 2 for our lab here, and then we're going to do a serial begin. So this, remember, setup is for initialization. So we'll do another serial. We're going to do serial.begin, and then 9600, which is standard, and then all right. And then we'll do the void loop, and we're going to set up a variable inside the loop. This would be a local variable called y1, and then this one's going to be an analog read. So analog read A0, and then we'll do a serial print y1. And then we'll do a delay. Alright, so that's going to be only 100 milliseconds, so it'll be a quick delay. Okay, so let's see. Let's go ahead and run this, and then we'll talk through what's going on. So let's go ahead and we'll compile this. While that's compiling. Okay, so before it's done now, it's done compiling. Serial monitor is still running and it's still executing the old code, so we'll just have that here. So let's talk about this before we upload it, because just real quick here. So the serial.begin, that's the command that starts the serial communication and sets the baud rate to 9600, which is pretty standard. It's the so the baud rate, it's the rate at which data is sent between the device and the serial connection. So in this case, the way we've got this set up in between the computer and the device, and then the begin is just a command that starts the serial communication. And then next up we've got the void loop, which is the analog read, the serial print line. So we've got 3 things going on here. Okay, so the first one here, integer. So what we're doing is we're taking the integer, we're creating a variable called y1, and of a data type integer, and then we're doing an analog. We're doing an analog read off of the A0 pin. which is maps out to the input voltage, the operating voltage, and the integer value is going to fluctuate between 0 and 1,000 or something like that. 0 and I think technically 1,023. So it's going to fluctuate between that, but that's it converts the voltage output on that pin to an integer value. Then what it does is it prints that. So we're doing a serial print line, and we're taking the value that it gets and then passing it to this and then printing it out, and then we're doing a delay. So that's pretty much what we're doing here. So I'm going to go ahead and upload it now, and that should pretty much take care of this. And then it should upload. We should get and that should move. That should be communicating a lot faster. If we go to the serial monitor, you see this is what's happening here. So because of the way this is set up, it has the voltage, it has some sensitivity to the movement. So when I put it down, I kind of, not too hard, but if I just move it around, it's going to have some adjustments to the voltage. Now, this is just a nice exercise because I want to show the serial plotter. We're looking at the monitor right now, but now what I want to do is bring the plotter in, and so we can actually show what's going on right here, which is it's shown where the voltage is between 214 and 213. I'm going to assume that's like in the 3.3 volt range. Now if I play around with this, it changes the voltage. See what happens is it lowers the voltage, and then the voltage went up, and then now it's going to stabilize. It's going to go back to the 213, 24, so it's staying right around here. But again, if I start playing around with this, it changes the mechanics of what's going on here. I drop it. Don't hit it hard, but then it spikes, and then if it goes to resting. So when I bring it up like this, it's kind of interesting. When I pick it up, I get a drop in voltage, and then when I all I can figure is that the voltage is being impacted by the accelerometers and the other hardware that's on here. So as I play around with different things, just for if I hit the button, it resets it here. But there's little things here that I'm just kind of putting my hand on this, and it as I'm touching it, it's playing around with it. Anyway, so there you go. You can play around with this and get a feel for. There's other things you can do and test out what the voltage. This is just a voltage. This is a voltage readout. And so as we put more hardware on here, this voltage readout would change if we wanted to do this and do an A0 readout as it relates to any project we might be doing. Okay, that's all we've got for this exercise. So we've done two things. So here's a recap. We created in our first exercise, we created a program that really was focused on explaining the common syntax of the Arduino programming language. And then in the second exercise, we got familiar with how to do plotting, and again, another smaller program, but that gets us it working, right? Gets us more comfortable with it, and of course we'll get more comfort as we move along with this. The Arduino Uno R4. Okay, well, on the next one, this is going to be fun. On the next lab, we're actually going to create a breathing. It's a breathing LED, and we'll be breaking out the breadboard, breaking out a resistor, an LED, and some wires, and connecting up, and actually, flexing the kit a little bit. So that's all we've got for this one, and we'll see you in the next lab.